Okay, welcome back to another live stream. I'm still coughing and I apologise. I listened back to the previous episode and yeah, my coughing's pretty bad. Getting better, hopefully. Well, I am. So, should be less coughing this episode. There is still going to be some coughing. It doesn't matter how much I drink. So where were we yesterday? We left off, we had got a string internal working, we got some basic number parsing of a string number recognition in the Alexa going. We've got the identifier going along with a small bit of identifying keywords, and we've just started to add some simple tokens like braces and curly braces, resisting the urge to cough. I've turned the mic down slightly, the gain on the mic down slightly, so hopefully the coughing won't be so bad, and hopefully the keyboard noise won't be so bad. I'll try and, at some point I will put something under it, find some matting or something. It's on a wooden table. It's a DAS keyboard, which is mechanical keys, which are quite noisy. I've had complaints before from people in different rooms, so I'm not surprised that the mic's picking up quite well. So let's carry on where we were. Right, first thing I want to do is the other thing was I was talking about maybe adding some debug output for the Alexa. I've actually decided against that. The tokenizer is pretty simple, so I think I'm going to go with, there's probably some bugs in it. We will just go with the idea that the bugs will fall out when we write the parser side of things fairly rapidly. This isn't difficult code to debug. Right. With that in mind, Unary was a silly name. Let's change that to match. Then we're going to go up to our enum class. I made some notes, some small notes, and we're going to start to add in the missing tokens. So that will add the else one in. So we can now add keywords while, if, function, fn, and else. There will be more. We need the types, and return would be another good one to add. Keyword return. Let's just do one at a time. Hopefully the keyboard's not quite so bad. Looking, I probably ain't going to stream for about an hour, but looking to get a lot of the Alexa done today, which would mean we write Alexa in roughly 2-3 hours. Well, not debugged it, so that's not the total time. But, what else do you want to get rid of? Let's add keyword void. Might call it nil eventually, but maybe use nil instead. Honestly, doesn't matter. It's at the moment it's just getting something running that represents no return type, void thing. Oops, void. The moment I start talking, throat goes dry and I want to cough. I was wondering when when it becomes better to use a hash table rather than just a collection of ifs. I mean, these are comparing against integer values, so I would imagine there's a fair number of them can exist before the lookup, before hash table starts to save you some time. Probably not a fair number. I don't know. I've got no feeling for it. So, right. What else have we got here? Well, as that's a type, why don't we add a few more types in? Keyword. Ooh. And then we're going to need true and false, aren't we? Let's do them all at once. Keyword true. Keyword false. True, false, true, false. True, false. True. False. Check that all builds. And finally, let's go add a couple of integer types. I'm going to avoid adding char at the moment because I want to think about strings, whether to do a pointer star one or have a built-in string type. Keyword I32, keyword I64. I'm not even proposing that we support all these types at this exact moment. I32, I64, I64. So taking a leaf out of, I guess, Rust book really. Typing int or int64_t is a pain. So let's abbreviate as much as we can. I32, I64, I32. Some code bases I actually type def this up in C++ and use I3264s, 3264. Other code bases, I don't worry about it. Right. I think we're nearly there. Okay, why don't they think like that? Probably a spelling mistake. Yeah. Good. That will be enough types. That will give us something to infer against when we do some typing inference. And we shall move on to the next things, which are all the comparison operators. What else have we got missing here? We need colon, and we need semicolon. I'm trying to talk softly so I don't cough too much. Oh, don't want to do it like that, do we? We've got our match to do this. Semicolon. Colon. Math operators tempted to allow plus equals, but initially I think I'm just going to go with not having that plus, minus, multiply, divide. We'll add plus equals and stuff later on, but for now not going to. Oops. Right, and then we need some comparison operations. So, and assignment. So assign, which is going to be equals, and equals, which is going to take additional double equals. No point diverging from that. Now we have to write another macro, but let's write out a sample code from which we can then work with. So we check we haven't hit the end of the file, and then current equals another equal sign. Lo and behold, we have an assignment. So let's move past that. And you need a star there. Tokens dot push back. Let's have a little look. I cannot remember. ID is going to be 0. Line num type doc type equals. I'm not enjoying the order of these. I really want to make these fine, the first one. I might go for and change that at some point. That should build. Cool. Let's make a match to macro. Define match to C1, C2, type 1, type 2. Should do that in a second. So case C1, move along, case value C2, got it is right, C2 is type 2, and this is type 1. There we go. So effectively I've just made a macro out of the code I wrote, which will let us do stuff out of mode match 2, and the first one's equals, and the next one's equals. Sign L dot type equals. That should play through okay. Yep. Now I will probably end up replacing the pluses in the basic mathematical symbols with a match 2. When we do plus equals, so it'd be plus, and then the second line would be a plus equals plus a sign probably. For now I'm not doing that, but we have plenty of others to do. So we have less than equals, greater than equals. Followed by greater than equals, so greater than equals. Less than equals. Cool. Now I've probably forgotten a few things, but we've got functions, so we can create functions. We can lex functions. We can. We don't have a way of looping. Is that going to be a big deal for me? We've got while loop, and we've got some Boolean expressions to test it all. And we've got ifs. If else while function return integer. Right. So I reckon we're getting pretty close to having that workable. So the main API is it tokenises something and it doesn't hold on to anything, it's just the function call, and it just returns a vector back out. So I think we can, oh, excuse me, neck. Right. Tokenize. I don't know why, but it just bothers me that it's not quite right, but I've never taken the time to figure out a different template, because I'm pretty certain C-line will let me. You should be static. As should you. Now, probably above here. Hash include. Well, we don't need to. Yes, we do, because no, we don't need it. Tokenize. I don't reckon we need it. We're going to include it in the header file anyway, so. small. So I think that was in 32, 64 bits, 8 bytes. Well, that's going to be 4 byte lines, so 12 bytes a token. That's perfectly fine. Hash. Just doing it this way. Type. Where did you put it? Include. Trouble is, I actually prefer that is unfortunate to go in the header file. We may reduce our dependency on standard library. It's the in thing to do these days. The ultimate in public. The minimum data structures plus one function to generate a vector of tokens. Minimum complexity and in the header file, well not minimum because we've got including vector, so you could go more minimal, but in terms of understanding other than my English spelling of tokenize, it's a British spelling of tokenize. Conceptually pretty simple, but it won't compile yet because we don't know about string IDs. Yes, we do. Let's see if that builds. Cool. It built pretty quick, 621 milliseconds. Check OBS is happy. Yep, it sure is. And let's check streaming health. Yeah. Right. Oh, actually got as far as I expected to get. So, the rest is a bonus. What are we going to do next? We're going to write a parser. That's going to take our tokens and it's going to generate an AST. So this will generate abstract syntax tree. It's going to create a tree that gives us a structure of the program. It's going to remove things like white space, hence it's slightly more abstract than the textual description. It would remove comments and anything else that's surplus to understand in the program. We're going to use a fairly common method, recursive descent parser. Time to write the Lexa prox 2 hours. Not yet. That's pretty good going. If I was going to use a, it's not as efficient as a machine generated one, that's for sure. But if I was going to use one, it would take me more than 2 hours to read the docs and try and get something working. Some of them don't support Unicode very well. Alexa doesn't, but it's pretty easy to add that when we need to. The hardest bit will be when we just decode UTF-8 characters, because they can be 1, 2, 3 or 4 or 4 bytes long. But that's not a big deal. Well, that was a loud cough. So quite happy with that. The ones that do support UTF-8 Unicode tend to come with a slightly larger library associated with them. So you often take a cost in the size of the hit. So things like Antler come with a library you have to link in. The chances are, to be honest, I shouldn't pick Antler out because I never really used it, but chances are it's not going to be a big deal. But while I'm not aiming for a minimal size code size, I am wanting it not to sort of go, I want it to be fairly small. I don't want it to be 15 megabytes in size or anything like that. And the goal is to do what we do minimally. So I've got pretty much all the tokens. The Lexa's pretty much going to produce all the tokens we need. We've got some types, so we can do some typing ferns. And from that we can do type check, typing ferns, type check. First of all, we've got to write a parser. Write the parser using the recursive descent method, which is a nice way of doing it. Then we do a type check over the abstract syntax tree generated along with typing ferns. They kind of go hand in hand. From there, we will have a go at compiling it down to a bytecode. I've not done that for a long time. So that's probably where we'll slow down. That's fine, I think it'd be interesting to do. And the other thing we need a way to report errors. I haven't decided whether we're going to put error recovery into the parser or not. I'm tempted to say yes. I actually only have written one little parser that does that, so that may slow us down a bit. But we'll see. You end up with a parser in a separate mode, a panic mode, that when you start emitting AST tokens, it doesn't actually bother to generate them, it just keeps returning null. And you fall down into maybe where a semicolon ends a statement. At that point, you exit panic mode because you're starting a new expression. And off you go. So you can generate more of the AST. What you don't then do is try and do any type checking on it. But let's start thinking about the data structure. So we want a node. I'm going to call it node because we can always namespace this stuff up if we need to. So we'll have a structure. It can be a node. Node is going to have a type, which we're going to call AST type, which instantly makes me want to change this to AST node. I'm going back to myself again already. We'll make that an enum class viewing date type and module code block identifier, which really will mean variable in this case. It can mean lookup value or can mean error value, which means it's on the left side, so an L value equals 10. That's what we mean by an L value. It's on the left hand side of an assignment, so we're going to assign to it. Or an R value, which is used in expressions, so 10 times R value equals, and it's on the right hand side of an assignment. It's also used in a function call. So should go like that. I'm wondering whether to distinguish them or not. Both L values and R values at the moment. can be an if. State. Could be a wireless state. Could be an add, minus, divide, multiply, put you there. Could be sine equals, call that quality, quality test, quality check, just call it quality. Greater than, less than, greater than, equals. You see, instantly change that to equals because we want consistency. Less than equals. So if we quickly go back to tokenize, oh, we've got all the keywords. I wonder if I can split the screen somehow. No. Nope. So got integer value I32 I64 forgetting true, false and ball. You know what? Let's go and types. Type ball, type true value, false value. Now we've got our types. Oh, got our types. Now we need to return and function. Return statement. Fn declare. Fn call. Integer, which is the value, invalid, I'm not worried about. And that's all those. We're not going to have semicolons or braces because they're all redundant. Once we parse it, you don't need to be aware of those anymore. The tree reflects. These are syntax to give the text structure. We're parsing that, we remove that structure and replace it with the implicit structure of the syntax tree, which is why they don't appear in our node count. And why I keep jumping back to their main. Okay. Now, that there. Hopefully you can still see that. Little guys that are missing their commas. Excuse me. And, probably do some renaming on these as we use them. Why is that complaining? I haven't given it a name, have I? AST type. Here we go. All is good. We have that. Now, we are not aware of the size of the integers values. We are not necessarily got two options. Oh, I hate thinking about AST nodes. So most of them have we can model it like this. We need an int line num. What I don't like about that is we've got a crazy amount of allocation going on, so it's going to be pointer chasing everywhere. Each node has a vector of its children. What I do like about that is quite nice. So plus would just have an HS and left hand side and right hand side. So the binding operations are quite simple. A function type, function declaration would have name, parameters, which in itself would have children, and then a code block, which in itself would have children. You can see we haven't got parameters there, so it tells me. In fact, yeah, we don't. Function call would have a name or an identifier. And args, which is children. This is ignoring the fact we need to associate types with it, which will probably be another ID specifying the type, a unique ID for that type. Yeah, we'll see how it goes. That storage of types. So two things are missing is parameters, formal parameters. Have to have type info. So we need a type declaration. Let's put these down here. Type decal, which would have an identifier, would be two identifiers. Too much going on. The alternative to this is we have a union of structures and not C++. One would be a binop. That would have an RHS and an LHS. Another would be struct unary, we should just have a child. Struct fn decal block. Punch this, everything's named. Disadvantage this is we've got the problem that this wants to be a vector of some type, and we use I to dispose of it. That in Union's not a good thing. You've got to, when you destroy your Union, you've got to know which type's in there, and you've got to call it destructor. It's doable, but it's not great. Alternatively, we use the standard variant or boost variant. Those, well, I'm not quite experienced with standard variant, but boost variant is such a pain to debug. You struggle to look into it. I've never got the visualizers to work very well on any IDE. The alternative is that we create a linked list. So your code block would just be, you'd have a next here, AST node child, point to children, and then AST node sibling to point to your brothers and sisters or people in your there. I'm not sure. It's difficult. The moment you've got this, we could use unique pointers for this sort of thing. Feels like a bit of an overkill. We'd probably want to write a little, well, could write a memory arena. Arena. Pretty simple to write, but I don't want to write one. So if I take this route, I will probably accompany the AST nodes would be struct AST, and then we do AST node root and stood vector AST node stars. Nodes. Then every time we want a new node, we just create one, allocate it, put it on here, and at the end we just loop over them and delete them all when we've got the destructor. Again, you could use unique pointers. I'm probably thinking both have their pluses and minuses. This, not exactly memory efficient. It also, but ignoring the engineering side of it, it also means that I have to remember the order of things. I have to remember that the first child is the identifier, second child is the params, got to know the type info and all this, you know, pain. The union approach makes that explicit. I switch and I know which type's in there, and all is good. I avoid the vector problem by having these guys here, siblings and next, so we're only storing, we wouldn't store that. We might actually. If we did, it would be a vector pointing to the first child in the code block, and then you would get the others via the sibling. Navigation's a bit more of a pain, which is, you know, not great. The excuse me, construction's slightly harder. We can probably wrap up a few classes to make it easier, but you have to keep, you know, we're effectively having to nest in our linked lists. Maybe standard linked list would help us, but link list, isn't it? It's been so long since I've used it. Possibly, but possibly not. It's all got. It's an external linked list, which means more allocations. Did they add a external linked list? think this approach will probably get me there faster. I've done both in the past. This approach probably get me there a little slower, but in terms of getting it written. But I've got a feeling later on it will be a little bit simpler when we're doing our typing ferns. Of course we're going to have a, not there, but eventually we will have a type. Info, pointer, type. And everything will be given a type. Maybe void, maybe nil, whatever we decide to call it. That will be the job of the typer, to roll over, figure out types, keep figuring them out until it's done them all. If it can't figure something out, cry. Well, complain and upset the programmer. My silly coding. Which one would I prefer to do is the question. Could do both. Which one's best? No. I reckon I'm going to go to Union White. It's one I've not done for a while, so in fact it's been so long I'm not even sure. Union. I wonder if we can do anonymous unions. Last time I used them was in C and they have slightly different. C11 accepts things that C++ 17 doesn't. Maybe. Okay, I'm not worried about the ordering of these things, but I am worried about their initialization. So null pointer. Null pointer. -1. That I think I'm going to force it to be done. Okay. Structure AST node full declare it. Struct U. Just write a couple of these down. AST node child. Just so we've got struct. This is going to be things like -10. So that is not a binary operation, it only has one child, one operand. So there's going to be a few of those, and a unary plus as well. Struct binary op. Oh, look, you see, we're getting this wrong. There we go. And AST node HS. OHS. Unary op. Unary. Binary op. Anyway, a couple of things like if you want something consist in all of them, we want to pull it out, so we might decide to pull out strid, strid, for instance. Maybe we will, maybe we won't. In the case we'd want to minimize number of allocations, so if we come across an identifier that tokenize a found identifier which knows the function name, we just want to store it as a secure ID. We don't want to create a new node for it called identifier, which is then stored as a pointer inside the function declaration. For instance, we have another one called struct fn decor, and we'd have another one called struct fn cool. Awesome. And I've just realised that we've forgotten another keyword we missed out. Let tokenize might be var, might be better, but the actual strings are easy to rename, and the variables easily rename because CLion has some good refactoring tools, as does Visual Studio and many others these days. I recall the, let's think, way back, SlickEdit was the first IDE text editor that I know of anyway, that attempted to rename refactoring on C++, and it wasn't that good. It worked simply if you were doing some C stuff, but the moment you did any templates or had anything complicated in the code, like macros, it just gave up and couldn't even parse the code. That was a long time ago, 2003, 4, 5, I can't remember. I don't even know if SlickEdit is still going. Let's have a look. SlickEdit. Going to load. Whoop, been streaming 53 minutes. Yes, it's still going. I'm trying to find some sort of when was it last updated thing. Here it is. Cost you $99. I guess you'd want SlickEdit Pro these days. It's got debuggers, integrated builds, Java. In its day, it was pretty much the best editor out. Now, what I'd really like to know is, let's go to the blog, see how active it is. Are they still doing stuff? 2015, that doesn't bode well, and a website that's straight out of not 2015. And I'm not planning on buying it, but if I was, knowing that their blog was last updated in 2015 is a fairly bad thing, because normally you God, it's not even talking about SlickEdit really. Maybe that is. Yeah. Oh well. Nice distraction. Trip down memory lane. And it was pretty cool. And I was one of the years I actually got into scripting, and I was writing quite a lot of things to help. I wrote a script to automatically add in the header files when I needed them, and the declaration. Speaking of which, I got this wrong. It's not a declaration, is it? It's a definition. Declaration is we need to declare it. We're not going to need to forward declare things in this language. We're going to only going to define them, and it's going to know about them. maybe. Right, so return a node. Actually, we're going to return that. And this is going to have a destructor, AST. We're not going to declare from it. And we're just going to do for auto star n nodes. Hey. Delete n. Then to do replace with memory arena when I get round to writing one. I've got a few kicking around in my drive, but it's always fun to write one. And memory arena, we're probably only allocating some, maybe a memory pool or similar. We're only allocating one type or similar. So, why I'm not just using a vector of AST nodes here, because vector reallocates when it gets filled up, which means it moves things around in memory, which means they're not pointer stable. Therefore, I can't point into it. They could be another way of doing it would be to just have these as ints. That adds a doesn't add. You then have to use a function, or you have to wrap it up to say get child, which is another way of doing it. It destroys the. Should we try that? The size T's, there's still 64 bits. So there's no change there. So what I'm thinking is, instead of having pointers here, which obviously leads to an array, index 0, 1, what is it doing? 2, and then we have a pointer to my AST node. That one might point, and this might be a pointer to AST node. We don't make use of the index here. If these become size T, then the order is stable, so when they move around in memory, we can still index them. My own concern is a slight pain to keep getting them out. We have to put a bit more logic in here when we want to walk things. But we don't have to do that. We can still replace it with memory later on if we decide to. Let me check my phone. And I think I'm going to call that a night for now. And we should actually get on with creating the parser. Either I'll do it a bit offline and show you what I've done, or I will carry on tomorrow night. Okay, thanks a lot and good night.